Hello, everyone. Today I will walk you through a practical case of mechanical part measurement, with a focus on transforming image pixel coordinates into physical coordinates in the image. Let us now see the steps for mechanical part measurement. One. Preliminary setup in NV Viewer software. Open the NV Viewer software to acquire images. Set the IP address of the black and white 2D camera. Connect the camera network cable and 12 volts DC power cable to the Ethernet port and power supply respectively. Adjust parameters in the camera and common parameters section to obtain a clear image. Once the clear image is captured, close the NV Viewer software and open the KiMage software to measure the mechanical parts. First, set the light channel parameters. Connect the parallel backlight and the tricolor top light channels in sequence. Set the light source channel parameters as shown. Set the PLC parameters as shown. After setting parameters, proceed with the calibration work. Create a project named Mechanical Parts Measurement. Note, for experiments involving measurement only, without sorting, the XY calibration tool is generally sufficient. Therefore, the first tool group defaults to the XY calibration tool group. Double-click to open the tool group. Add the PLC control tool, light source control tool, and camera tool. Double-click to open the PLC control tool, enable the homing setting and click Release Interruption, Execute. Each new project requires homing. Double-click to open the light control tool and set the brightness of the backlight in the light source tool to improve image clarity. Place the calibration board on the motion platform. While clicking the Run button of the camera tool, use the control joystick to move the motion platform directly beneath the camera, ensuring the captured image includes the complete calibration board. Double-click to open the PLC control tool in the parameter setting interface. Check control setting. Get position and click Release Interruption and Execute. Then copy the X and Y axis positions from the axis position interface and paste them into the motion settings section, clicking Release Interruption and Execute. Click the Run button for each tool in sequence. Add timer and light source control tool. Double-click to open the timer tool. Set the delay time. This light source tool is designed to adjust the brightness value of the light source to 0 after taking the photo, in order to reduce energy consumption. Add circle finder tool and XY calibration tool. Double-click to open the parameter interface. Click the Register Image button. Frame a complete large circle in the image display area. Set search direction to from outside to center and polarity to white to black. Click Execute. Double-click to open the parameter window for XY calibration. Enter the radius pixel values identified by the Circle Finder tool in the X and Y pixel distance fields, and input the actual radius value of the selected circle in the actual distance field. Finally, click the Execute button. Validation method. In the parameter interface of the XY calibration tool, observe the X and Y pixel equivalent values in the output parameters. If the values are very small and identical, the XY calibration is successful. The calibration tool group does not need to be executed continuously. Execution is only required once during the project setup stage. At this point, the calibration work is complete. Remove the calibration plate and replace it with a tray for placing mechanical parts. Next, begin the mechanical parts measurement process. Since 4 parts need to be measured, create 4 measurement modules. Create a new module. Rename it Plate 1. Double-click to open the workspace of the Plate 1 module. Create 2 tool groups. The first tool group is for the imaging position, and the second is for measurement. The imaging position tool group scans QR codes on the components to identify various numerical values. The measurement tool group measures component dimensions and performs range checks to determine if they fall within the tolerances specified by the QR code data, thereby assessing whether the components meet quality standards. Double-click to open the capture position tool group. Add the PLC control tool, light source control tool, camera tool, timer tool, and light source control tool. The first light control tool illuminates the backlight to a certain brightness before image capture to enhance clarity. The second light control tool reduces the brightness value to 0, all 4 channels, after image capture to conserve energy. Double-click to open the parameter interface of the first light source control tool and set an appropriate backlight brightness value. While clicking the Run button of the camera tool, use the control joystick to move the motion platform, ensuring the captured image includes the complete mechanical part. Adjust the light brightness based on the displayed image until the QR code on the component is clearly identifiable. Double-click to open the parameter window for PLC control tool. In the parameter settings interface, enable control settings. Acquire position. Then click Release Interruption and execute. Copy and paste the X-axis and Y-axis positions from the axis position interface into the motion settings. Double-click to open the timer tool, set the delay time. Add the QR code detection tool to verify successful QR code recognition. If recognition fails, adjust the brightness of the light control tool and parameters such as exposure, gain, and gamma in the camera tool. After debugging, the QR code is successfully recognized. Double-click to open the parameter interface of the QR code detection tool and drag its output parameter search results to the image display window. Then exit the imaging position tool group and open the measurement tool group. The first step is to add the shape matching tool. This is because the measurements for the subsequent 3 components are based on copying and pasting the first component's program with minor adjustments. The shape matching tool helps identify common features across all 4 components. Double-click to open the parameter window for shape matching tool. In the Basic Parameters tab under Tool Binding, click Input Image to open the Variable Reference interface, referencing the output image from the camera tool in the Imaging Position tool group. Exit the reference interface and click Register Image. In the image display window, select the template area. Sequentially click Set Center, Create Template, and Execute. Fine-tune the basic parameters to improve matching accuracy. Add Circle Finder tool. Double-click to open the parameter interface. Click the Register Image button. Frame a complete large circle in the image display area. Set search direction to from center to outside and polarity to white to black. Click Execute. Click the parameter interface. Drag the circle diameter result from the output parameters to the image display window. If the diameter value is excessively large, it indicates the camera tool in the Imaging Position Tool group did not reference the XY calibration. Return to the camera tool's parameter interface and reselect the calibration. Rerun the Imaging Position Tool group to successfully reference the XY calibration. Reopen the parameter interface of the Circle Finder tool and confirm the circle diameter has returned to normal values. Then, drag the circle diameter measurement result from the Output Parameters section of the parameter page to the image display window. Modify the displayed text. For standardization, rename the first Circle Finder tool as Large Circle. Next, add a second Circle Finder tool. Rename it Medium Circle. This tool locates the medium circle in the upper left corner. Add a Point Distance tool. Rename it Large Circle, Medium Circle Center Distance to measure the distance between the centers of the large and medium circles. Double-click to open the parameter interface of the Medium Circle tool. Click Register Image. Select the medium circle in the upper left corner. Click Execute. Double-click to open the basic parameter interface of the Point Distance tool. For the first point input field, reference the circle center point data from the output parameters of the first Circle Finder tool. For the second point input field, reference the circle center point data from the output parameters of the second Circle Finder tool. Click Execute. The image display window now shows the distance between the two circle centers. Reopen the Large Circle, Medium Circle Center Distance tool's parameter interface and drag the point distance value to the image display window. Modify the displayed text. Next, add two more Circle Finder tools and a Point Distance tool to measure the distance between the centers of the semicircles on either end of the long bar. Double-click to open the parameter interface of the first Circle Finder tool. Click Register Image. Select the left semicircle of the long bar and click Execute. Double-click to open the parameter window for the second Circle Finder tool. Click Register Image. Select the right semicircle of the long bar and click Execute. Double-click to open the basic parameter interface of the Point Distance tool. For the first point input field, reference the circle center point data from the output parameters of the first Circle Finder tool. For the second point input field, reference the circle center point data from the output parameters of the second Circle Finder tool. Click Execute. Drag the point distance value from the output parameters section of the parameter page to the image display window. Modify the displayed text. For clarity, rename the measurement tools to reflect their purposes. Save the configuration file. Now, measure the distance from the endpoint of the large keyhole to the bottom edge. Add the Line Finder tool, Point Finder tool, and Point-to-Line Distance tool. Double-click to open the parameter interface of the Line Finder tool. Click Register Image. Select the short edge of the component's recess. with the arrow direction perpendicular to the edge, from black to white, and adjust the grayscale threshold. Click Execute. Double-click to open the parameter interface of the Point Finder tool. Click Register Image. Select the lowest endpoint of the large keyhole, with the arrow direction perpendicular to the edge, from black to white. Click Execute. If the endpoint is not detected, lower the search threshold value for better recognition. Double-click to open the basic parameter interface of the Point-to-Line Distance tool. Reference the endpoint coordinates from the Point Finder tool's output parameters for the point input and the line coordinates from the Line Finder tool's output for the line input. Click Execute. Drag the distance value to the image display window. Modify the displayed text. Add 2 line finder tools and a line distance tool. Measure the distance between the short recessed edge and the long edge of the component's right side square hole. Double-click to open the parameter interface of the first line finder tool. Click Register Image. Select the long edge. Click Execute. Repeat for the second line finder tool, selecting the short recessed edge with the arrow direction perpendicular to the edge, from black to white. Double-click to open the basic parameter interface of the line distance tool. Reference the line coordinates from both line finder tools for the 2 line inputs. Click Execute. Drag the distance value from the Output Parameters section of the parameter page to the image display window. For clarity, rename the measurement tools to reflect their purposes. Add 2 line finder tools and a line angle tool. Measure the angle between the slanted edge and the side edge. Double-click to open the parameter interface of the first line finder tool. Click Register Image. Select the component's outer edge. Adjust the grayscale threshold and set the arrow direction perpendicular to the edge, from black to white. Click Execute. Repeat for the second line finder tool, selecting the slanted edge at the upper right corner. And adjust the grayscale threshold for better accuracy, critical for subsequent references. Click Execute. Double-click to open the basic parameter interface of the Line Angle tool. For both the Line 1 and Line 2 input fields, reference the line coordinate data from the output parameters of the Line Finder tool respectively. Click Execute. Drag the value between distance from the output parameters section of the parameter page to the image display window. At this point, the measurement tool group is complete. Note, before full execution, right-click the image display window, select Binding. Manual Binding. In the Manual Binding interface, enable the Output ROI and Contour ROI options for all tools in the group to ensure data refreshes automatically during repeated executions. Click OK. Now, run the entire module once. The display is normal. To simplify the display, uncheck the arc names of some Circle Finder tools and the line names of some Line Finder tools. Run the module again. The display is now cleaner. Next, set tolerance ranges to determine if measured values fall within the allowable error margins stored in the QR codes. First, set the range for the large circle tool. In the Parameter tab, click the Settings button next to Circle Diameter in the Output Parameters. In the Judgment interface, select Range as the type and set the maximum and minimum values, for example, 14.81 plus or minus 0.8 for the large circle diameter stored in the QR code. Similarly, set ranges for the large circle, medium circle center distance, point to line distance, and line angle tools based on actual requirements. The allowable tolerance range shall be configured according to actual requirements. Run the module again. The point-to-line distance turns red. It indicates the dimension is out of tolerance, and NG should be displayed. Drag the measurement tool group's results to the window. Adjust text colors and other display parameters. Grid the window. Set the Plate 1 module as the starting module and run it again. The results show this plate is defective. Repeat the process for the other 3 plates. Add 3 more windows to display the measurement results for all 4 plates. Duplicate the Plate 1 module and rename it. Since the subsequent plates are based on the first, ensure the first plate setup is correct. Click the second window and set it as the main window. Enter the Imaging Position tool group of the second module. Use the Light Control tool and Camera tool to position the motion platform for capturing the second plate. Acquire and record the position. Then copy the X and Y axis positions into the motion settings. Run the tools once. Drag the QR code detection tool's search results to the image display window. Exit the Imaging Position tool group and open the Measurement tool group. Run the tools once. Run the entire module again. The image display window does not update. It is because that the component position is changed, requiring re-execution of shape matching. Drag the shape matching tool to the image display window, right-click, and select Binding. Manual binding. In the popped-up interface, enable Output ROI and Contour ROI for all tools in the group. Click OK. Run the entire module once. Before running, drag all required results to the display window and configure font, size, and color as needed. Run the entire module once. Repeat these steps for the third and fourth plates. Now 4 plates are configured. Run the complete process to verify the results. Alright everyone, this concludes the hands-on demonstration of mechanical component measurement. It may seem complex, but practice makes perfect. With repeated exercises, you'll master it effortlessly. Thank you all for listening, and see you in the next class.